I'm going to go through the Ventrain and the CryCath with you today and go through the components and how I do an in-service on the device. First thing I will do is actually get them to get their box out of their own difficult intubation trolley. So you've actually got that to show them their physical device and talk with them about where they actually keep it and the scenario around when they might need to use it. I would propose that typically when you get to the point of needing to use a needle cricothyrotomy kit, your patient's in a lot of trouble, so it's really important to be familiar with your kit that you have on your trolley and know where it is. The beauty of the way it's packaged, and I don't have one to show you in the way it's packaged at the moment, but the beauty of the way that it's packaged is that you can open that box at any point in time and not disturb the product and become familiar with the product through the way that you can actually visibly see it. And also that you have these two little books that should be in there, one on the Ventrain and one on the CryCath. They're written in multiple languages, but the first few pages are in English in either of those. So it's a really good quick reference guide. And I also provide this to all of my customers. I believe this is on SAM as well. It's an A5 version, an abbreviated version of what's in the two little books. I usually get a clinician, an anaesthetist or a ICU director or ED director to actually have a look at it to check that they're happy with the content of this form, purely because we wrote it and we took it from the books, but it's not everything. And this is probably what they're likely to go to in an emergency rather than the little books. So it's really important to get them to be familiar with that card. So if they open up the box, they can look at all of those things quite easily. You'll have two sterile pill packs, and one will actually have the Ventrain, and it's packaged like that, so you can actually see the device, and you can see some instructions written on the device, which are written on both sides. So that makes it really easy to be familiar with the product. And in another packet, you'll have the actual CryCath needle, you'll have some trachea tape, and a syringe. And the only thing they need to add is normal saline or water for injection in order to put into the syringe when they're a testing position. To demonstrate the product, I'll also make sure that I've actually got a test lung and oxygen available. If you're in an operating theatre, typically if it's an anaesthetic machine, it might only dial up to 12 litres, and you need ideally 15 litres to deliver to your patient. So if in an emergency scenario they could use an anaesthetic machine and then attach it to a delivery system that will take you up to 15 litres. Obviously a portable cylinder is great for demo in an education sort of setting. Okay, so to get started, the first thing I'm going to do is actually talk about the catheter itself. So this is a CryCath. You can see, okay? And the CryCath is very sharp, so you do have to be very, very careful. It has a little cover that you can take off to demonstrate the needle. And essentially it is meant to be curved in that position there. And the little flange on it that makes it quite unique is hinged, and it's meant to be on that angle that it is there. The reason that it actually has that angle is that when it's in position, I'd actually pull that needle out, the stylet out, in order to see it. But when it's actually in position, it actually helps that flange seat appropriately, so you're actually going to get a nice flush fitting to the neck, and that angle also will help it position correctly. Being a curved needle, the benefit of that essentially is when they put the needle in, it reduces the risk of it popping through the posterior wall and then losing your airway. It allows you to sort of position the needle correctly, and I'll show you how to do that. And as I said, have a syringe half filled with saline or water for injection in order to test position. So to demonstrate the product, what I typically do is talk to the group around the position that you're putting the CryCath into, and that's the cricothyroid membrane, which if you go down here and you feel in your neck, you can actually feel that spot. It's actually quite tender to press it, and it's a little triangular shape, which is the cricothyroid membrane. The bottom third of that space has less vasculature, and putting the needle into that position will enable you to reduce the amount of bleeding when you're placing the catheter. So to place the catheter, they're going to, on our little friend the test lung, they're going to come in on an angle like this and then basically point it caudally down, so you're actually getting it into that sort of position in the patient. So we're going to pop that into our patient's neck. When you feel that pop, they'll have the syringe preloaded into the stylet, and we'll draw that back to see that they're getting bubbles in the syringe. So they haven't advanced it very far through the cricothyroid membrane, but they felt the pop when it's gone through. When they draw that back, they're looking for bubbles here. If they do get a little bit of blood, it can actually be a sign that you've maybe touched on a capillary or something like that. If they can't draw it back or they get a lot of blood, then that's a sign that you're in the wrong position and they'll need to start again, and we'd take the stylet and needle out. So once we've actually confirmed by having bubbles there, they'll further advance that catheter into position by pointing it caudally and going down and curving it into that sort of position, but removing the stylet at the same time. Carefully discarding that stylet, which is very sharp, putting that back in and drawing back on your needle again, on your syringe again, in order to see that you're getting bubbles and you haven't dislodged and moved out of the airway. And you're also hoping to actually make sure you haven't kinked the actual catheter itself. The actual catheter itself is a high-grade Teflon. It's quite rigid. It's equivalent in size to a 14-gauge Gelco. But the difference here is it's a high-grade Teflon. It's quite sturdy, and it makes it very hard to kink off and lose your airway because you're breathing through an internal diameter of 2 millimetres. So it's important that you're not sort of losing that airway. Some people traditionally use a Gelco. And a Gelco essentially does pose that risk of kinking quite easily. We know how easily they kink when they're in your arm. So obviously it's the same thing when it goes into your neck. It's even worse when it happens. So your catheter is actually in position, removing your syringe, holding onto that for dear life. Okay, so it's probably the nurse that's going to be assisting at this point in time. And it's a lure lock fitting on the top. So we're going to lure lock and connect that up, make sure that's nice and firm, and also make sure our other connection there is nice and firm as well. Depending on the facility that you're in, you potentially will have the capacity to do CO2 monitoring, and that's what that port is for right here. So that cap can come off and you can put your CO2 monitoring on there, but not if it's a side stream. It needs to be just a normal, typical 3-metre lure lock fitting, both end CO2 monitoring line that would go onto there. If they're not using it, just make sure it's closed so you don't have a leak. The other end of the device will go to your oxygen outlet, ideally at 15 litres. And I'll turn that on in a minute. So what we're going to be doing here is ventilating our patient. And at this point is when I actually show the device. So on our device we have instructions on the side. We have a port on top, just there, and a port underneath. And by holding the device like that, we'll be ventilating our patient. And it's literally a case of thumb up, thumb down, thumb up, thumb down. Now, because this device has a capacity to actively provide inspiration, but also actively provide expiration, so actively get the air in, actively get the air out, we're going to have an IE ratio of 1 to 1, whereas other devices, whether it's even if you're using a bag valve mask, if you're using a traditional needle crike sort of kit, the Rapid O2, any of the other devices all require you to do passive exhalation, which means you're getting air in under pressure, but then you have to sit back and wait in order for the gas to come out. And the reason you're waiting is you're trying to prevent barrier trauma. You don't want to put too much air in and not allow enough time for the air to come out. So I'll turn it on and show you. We'll wind that up to 15. And when I cover both of those ports, we have inspiration, so you can see the air going in. And when I lift my thumb, you can see we have active expiration. So the way I teach it is a 1-to-1 ratio. We're going to count 1 and 2 on, 1 and 2 off. So 1 and 2 on, 1 and 2 off. 1 and 2 on, 1 and 2 off. And you just continue that pattern, and then periodically it's a good idea to check in and do some passive exhalation just to ensure you've got reducing that risk of barrier trauma even further by allowing the gas to flow out naturally. I didn't have that connection on my cylinder. Sometimes that might happen to you too if you're using the same Ventrain repeatedly for training. What just happened then is that end just popped off my cylinder. I did push it on quite tight, but because these are a single-use item, it actually gets really soft and loose, and sometimes it might pop off your oxygen supply. If that happens, I usually just explain, well, that's just happened because it's single-use and it's not meant to be reused, and I've reused this so many times, so that fitting is loosening up. But obviously when they're using it for the first time, just to make sure that's on nice and tight onto the oxygen supply. So it's really a big deal. Hopefully that won't be a problem for you. So essentially going back to that IE ratio, we're going to go 2 seconds on, 2 seconds off, 2 seconds on, 2 seconds off. And then perhaps every 5 or 6 breaths, they can go 2 seconds on, both fingers off, and you'll have passive exhalation. The gas will come out very slowly, and you'll wait for 5, 6 or so seconds, and then go back to ventilating your patient. 2 on, 2 off, 2 on, 2 off, and so on. Okay. In regards to the setup with the patient, typically it would be the anaesthetist that's doing this, and perhaps a nurse standing by doing the count. And what I recommend is they do the count out loud, and be basically watching that patient like a hawk, watching that they're getting that equal rise and fall of the chest, and that they're getting periodically the opportunity to do some passive exhalation just to check in that they're not over-ventilating their patient. And then going back to that pattern of 2 on, 2 off, IE ratio 1 to 1. When you're delivering 15 litres a minute from your oxygen supply, you're basically delivering 7 litres a minute ventilation to your patient, which compares to about 2 to 3 litres a minute ventilation if you're using a system that only does passive exhalation. So by having that ability to actively take the gas out of the patient, essentially, or do active expiration, it assists by getting that higher minute ventilation to your patient. So there is a potential there that you can reduce the CO2 and have a better ventilation sort of ratio for your patient as well. Typical questions I might get asked is, can you use it on children? It does actually have a paediatric indication, so you can actually use it for children, but we only have the one size catheter. And in babies, you might want to use a 16 or an 18 gauge gelco instead of the needle, instead of the cricath. And if you are using it in children, you would need to use a lower flow rate, which might be around sort of 10 litres. There is a little table in the Ventrain book that explains to you the sizes of the internal diameter of the catheter and the flow rates you'd need to use and the ratios if you do actually alter from using the standard needle. But essentially 16 or 18 gauge catheter with a gelco with a lower flow rate of 10 litres typically would be around what you would use in young paediatrics. So what else I get asked? And how long can you use the device for? Essentially it's indicated for use as a short-term life-saving device. We're trying to use this in order to buy you time depending on the scenario. So the scenario might be that the patient's choking, and if that's the case, it buys you time in order to remove whatever they're choking on. If it's laryngospasm, buys you time to help reverse the patient and allow that to settle down. But if it's a tumour or something else, that obviously buys you time to get the right people there in order to put a more substantial airway in, and obviously that sometimes requires a group of people to put a tracheostomy into the patient, so it buys you time. So you don't want to use it for too long because it's managed and there's room for error in doing that, but essentially as long as you're maintaining that IE ratio of 1 to 1 and checking in to reduce that risk of barotrauma by doing some passive exhalation periodically, and really watching what's going on with your patient, I essentially say you use it as long as you need to in order to do something more definitive if that's what you need to do. But yeah, it is a short-term device, so hopefully they can quickly turn around the scenario that they're in. That's pretty much it. Good luck. Hope you don't need to use it.